In this video, you will learn how to solve this maths Olympiad question using a unique method. We are asked to solve for p using in the question 3 to the power of p minus 2 to the power of p equal to 65. Now learn how we solve this using one unique method. Now from this question, I want you to think of how we can solve this question in such a way that will arrive at a difference of 2 squared. As you think about that, don't forget to give this video a thumbs up. Also, kindly subscribe to my channel for more simplified mathematics Olympiad content. Now let's analyze that. If I want to send this equation to become a difference of 2 squared, since we have negative at the middle of this question, all I need to do is to look for a common term I can multiply with all through, a common power I can multiply all through. And remember, whatever I do to the left hand side, I'll equally do to the right hand side. So let's assume that I will multiply all through by the power of 2 divided by 2. There is a reason why I will use 2 divided by 2. Now let's get that started. So if I multiply both sides by 2 divided by 2, I'll have 3 to the power of p multiplied by 2 divided by 2, and this will be minus 2 to the power of p multiplied by 2 divided by 2, and this will be equal to what? 65 to the power of 2 divided by 2. Now, from the left hand side, you come to see that 2 divided by 2 is 1, and 65 to the power of 1 is still equal to what? Is still equal to 65. So that has not changed anything. So where we want that equation well applied is on the left hand side. Now let's look at the left hand side very well. From the left hand side, I will take you to a law of indices. In that law of indices, if you have a to the power of x multiplying the power of y, this can be equal to a to the power of x, y, right? Good. Now let's apply it here. If we apply it here, you come to see that this other side will give us something similar to this. We can now have this to become 3 to the power of p divided by 2, right? Because if p multiply 2 divided by 2, we have 2p divided by 2. So let's bring out the 2 out, and this will be minus 2 to the power of p divided by 2, and this will be all to the power of what? 2. Now you see that the question on the left hand side have changed entirely. Now what do I do from here? From this point, I want us to make an assumption. And what is the assumption? I want the 3 to the power of p divided by 2 to be equal to x. And I also want 2 to the power of p divided by 2 to be equal to y. So that means wherever we see that expression, we are going to change it to x and y. So that expression will now give us, this expression will now give us x to the power of 2 minus y to the power of 2, and this will be equal to 65. Great. Now what do we have here? We have x squared minus y squared equal to 65. Now you see we have difference of 2 squared. So what do we do from here? Now before we analyze this, I want you to note that 65 can also be broken into 2 different parts. 65 will be equal to 13 multiplied by what? By 5. 13 multiplied by 5 will give us 65, right? So that expression will give us x squared minus y squared equal to 13 multiplied by 5. Now let's take this gradually. Now from that difference of 2 squared, you'll notice that we have an algebraic formula that a squared minus b squared can be equal to a plus b, right? And it can also be multiplied by a minus b. That's an algebraic formula, the difference of 2 squared. Now, when we apply it here, we're going to have this to become x minus y or plus y multiplied by x minus y, and this will be equal to 13 multiplied by 5. So we have two different equations. Now from here, I can say let this multiply this and let this also multiply this. So we'll have two different equations. We'll have our x plus y to be equal to 13, and we'll take that to be equation 1. And then we'll have our x minus y to be equal to 5, and we'll take that to be equation 2. Now let's solve these two equations. If we solve these two equations, we're going to find out that we're going to arrive at an answer. Now I'm going to solve this equation using the substitution method. It's a simultaneous equation. Now let's do that. If we solve these two equations from equation 1, we are going to find out that our value of x will be equal to 13 minus y, because we subtracted y from both sides. So if we substitute this value of x equal to 13 minus y into equation 2, that equation 2 will now become 13 minus y, which represents x minus y, and this will be equal to 5, right? Good. So if we simplify that, we're going to have that expression to now be 13 minus y is minus 2y, right? Equal to 5. Now let's subtract 13 from both sides. We'll have minus 2y equal to 5 minus what? 13. So 5 minus 13 is going to give us a negative value. So we'll have a negative 2y to be equal to negative 8. So negative will definitely clear negative, and when we divide both sides by 2, what do we have for the value of y? We'll have the value of y to be equal to 4, and that is the value for y from that expression. Now remember, we said from equation 1. Now let's put the value of y equal to 4 into this equation, which is equation 1, which we derive for equation 1. If we do that, we have x equal to 13 minus y. So if we have our x equal to 13 minus 9, and we are imparting the value of y equal to 4. So the value of our x will be equal to 13 minus 4. And our 13 minus 4 will make our value of x to be equal to 13 minus 4 is equal to 9. You see that from this expression, we now have two values for the simultaneous equation, the values of x and y, which is 9 and 4 respectively. Now remember, I want you to recall that we said 2 to the power of p divided by 2 is equal to y, and 3 to the power of p divided by 2 is equal to x. And we are asked to find the value of p, right, from the initial expression. So we're going to substitute the value of p, x and y, into these two expressions. Now from that expression, we have the fact that 3 to the power of p divided by 2 is equal to x, and 2 to the power of p divided by 2 is equal to y. So let's substitute the value of x and y into that expression. The value of x will have 3 to the power of p divided by 2 to be equal to 9. And from this expression, we can simply say that 3 to the power of 2 is equal to 9, right? And then we'll have 3 to the power of p divided by what? 2. From the law of indices, we'll have same base. And since we have same base, the powers will equate. So we'll have p divided by 2 equal to 2. Let's multiply both sides by 2. P divided by 2 multiplied by 2 will be equal to 2 multiplied by 2. So p will be equal to, as this clears this, our P will be equal to 4. Now you see, we'll have the value of P on this other side to be equal to 4. Now on this other side, what would the value of P be? We have 2 to the power of P divided by 2 equal to our Y is equal to 4. So our 4 can be equal to 2 to the power of 2, and then we'll have 2 to the power of P divided by what? 2. So since we have same base, what do we have? Same base, the powers or exponents will equate. So we'll have P divided by 2 equal to 2. If we multiply both sides by 2 as we did earlier on, this will be equal to 2 multiplied by what? 2. And our value for P will be equal to 4. Great. Now you see those two expressions, P gave us 4. So what do we find from this expression finally? From this expression, we can find that the value of our P is equal to 4. Now let's test to see if this expression is truly right. 3 to the power of P minus 2 to the power of P. Will it give us 65? Let's test. We have 3 to the power of P minus 2 to the power of P. Will our result give us 65? Let's see. So this will give us 3 to the power of 4 minus 2 to the power of 4. Will it give us 65? 3 to the power of 4 is equal to 81. 81 minus 2 to the power of 4 is equal to 16. So 81 minus 16 is equal to 65. So what do we have? 65 equal to what? 65 on the right hand side. So that tells us that the value of P equal to 4 is a solution that truly satisfies that exponential equation that is given to us up there. I know you did enjoy watching these mathematics solutions. Don't forget to give it a thumbs up, share this mathematics solution with your friends and colleagues, and don't forget to subscribe to my channel before you leave this video for more simplified mathematics solutions. Thanks so much for watching, and bye bye for now.